from here, the older cells are getting pushed out. And if you slice into a finger, you can see part of the nail is in underneath some skin. So that skin is what we would call the cuticle. There are technical terms for it, but you don't need to worry about them. The nail itself is the nail plate. The skin it's lying on is the nail bed. And then lunula, which means little moon, is the little pale crescent area right at the proximal end of the nail. And that's there because it's a little thicker and is blocking out the blood vessels from deeper in the finger, so you don't see the pink through it. If you don't have a lunula, it's probably because your cuticles are covering it. Questions on nails? Hair grows in a hair follicle, which is a tube of epidermis that extends down into the dermis. I say down, but really what I mean is deeper. It's just when we illustrate skin in detail, we always put the open surface at the top. So the hair follicle is a tube with the hair growing inside it. The external part of a hair is the hair shaft. The part that's inside the skin is the root. So all of this is the root, not just the little thick portion at the base. That's sometimes referred to as the hair bulb, and that's where new growth is occurring.
Is it possible to pull that out?
Yes. If it's usually anchored in there, so if a hair is difficult to pull out, that means that it's still alive and growing. Most of your hairs, they'll grow for a certain amount of time and then stop and detach, and those are the ones that fall out more easily, and then a new hair starts growing in its place. And that's a big thing on why our body hair doesn't just keep getting longer, is it just grows a little while and then it gets replaced. Head hairs do that too. They grow for like 2 to 6 years depending on the person. Somebody like Crystal Gale, who had hair down to her ankles, hers probably grew for 6 years to be able to get like that. Mine, where I've got it now, about this long, is the longest it will get. It grows slower and probably for not as long. Whereas my husband's is fast. He can cut it to here, and then it's down to his waist before the year is out. And then he goes, why do all the women in my life want my hair? Because it's the best hair. Questions on hairs? I don't know if it's on the slide, but this muscle fiber I mentioned, that's what makes your hair stand up when you get goosebumps. And it's actually smooth muscle, it's involuntary. Sebaceous glands are your oil glands. They're found everywhere except your palms and soles. You want to be able to get a grip there, so you don't want it greasy. Most of them secrete onto a hair follicle, so they'll be on the side of a hair follicle. And if you cut in, you see little branching ducts. Just around the mouth and sometimes more of the face. And in the genital area, there are sebaceous glands that secrete directly onto the skin, places that don't even have the little thin hairs. The secretion is called sebum, and it has 2 functions. It keeps the skin and hair softer and makes them more waterproof than keratin alone. So you've got 2 lines of defense for keeping to prevent you from losing water through your skin, keratin and the sebum. Too much sebum can clog pores, which are the openings of sweat glands, and cause acne. So if it's clogged, bacteria start growing in it. If your mom told you when you were a teenager, don't eat so much pizza and chocolate because it gives you zits, no it doesn't, it's just hormones that make you produce more sebum when you're a teenager. Sweat glands are long tubes. The opening is through the epidermis, and then they're coiled at their deeper end, which is usually deeper into the dermis. Where they secrete is called a pore. There's three major types of sweat glands called merocrine, apocrine, and specialized. This one that's a little thicker and connects to the hair shaft is apocrine, sorry. Merocrine are the basic ones. So, merocrine sweat glands secrete mostly water with some salt and waste. That salt is why, if you've been sweating a lot, you might need to drink a sports drink instead of just water. Merocrine sweat glands are everywhere. They're especially abundant on the forehead, neck, and back, plus the palms and soles. And their function is just to reduce your body temperature. You put water on your skin, and when it evaporates, it takes some heat with it. Apocrine sweat glands are a little weird. They have some additional components in the sweat, like proteins and lipids. The bacteria on your skin can eat it, and the wastes from the bacteria is what makes that sweaty smell. Apocrine sweat glands don't become active until puberty, which is why little kids, no matter how dirty and sweaty they get, don't get that characteristic smell. Apocrine sweat glands secrete onto hair follicles in mostly the axilla. Somebody remember what the axillary region is? Armpit, and the groin. While they can help with reducing body temperature, they're especially active with strong emotions like fear, pain, and sexual arousal. It's thought that the proteins are supposed to be pheromones that signal other people about how you feel and maybe signal them to feel the same way or to come help you if necessary. While we're generally not consciously aware of pheromones, there have been some studies that show we do subconsciously acknowledge them. Specialized sweat glands are actually a variety, not just one type. They include ceruminous glands. Ceruminous means waxy. They produce your earwax. And mammary glands that produce milk. Your earwax is a lipid. Milk is a whole bunch of stuff. Water, lactose, proteins. Big variety intended to provide all the nutrients for young humans. Questions on glands? Our last thing is to look at some functions of skin, how they work. So, skin protects you. We already talked about that. The keratin is a little bit of a physical shield and it holds the water in, preventing water loss. Regulating your body temperature, that one we'll take a look at. Your sense of touch, because it's what is close to the environment. So it's equipped to detect what's near you. And skin synthesizes some chemicals such as vitamin D. That's all we're going to say about that. You might know that vitamin D you can make for yourself when ultraviolet light hits your skin. And that's actually why worldwide there's a common pattern of how much melanin people have. If you live further from the equator where you get less sunlight, the melanin blocking the UV also prevents vitamin D production. So if your risk of sunburn and cancer was less because you're getting less sun, it was more important to accept the UV to make the vitamin D. Whereas if you're near the equator, you're getting hit with plenty of sunlight, you need the protection more than you need the ability to make the vitamin D faster. Body temperature we looked at briefly in chapter 1. I will redraw our homeostatic mechanism. Your stimulus would be if your body temperature is too high or too low. Receptors are called thermoreceptors. Therm means heat. Control center is called the hypothalamus, which we'll talk about more when we get to the nervous system. Your effectors include two things in the skin. Your sweat glands, mostly the merocrine, and the blood vessels in the dermis. Also an effector for body temperature that's not in the skin is your skeletal muscles. The responses will depend on whether you're too hot or cold. Those blood vessels in the dermis are going to be involved to fix it in either direction. If you are too cold, you inhibit the sweat glands. You don't want to be sweating and losing more heat. You constrict the blood vessels in the dermis because blood transports heat. Wherever it goes, it takes the heat with it. If you send more of it to the skin, more of that heat can be lost to the air around you. So by constricting those vessels, keeping the blood and therefore the heat in the deeper tissues can keep you from losing heat. Those two things just keep you from losing heat. If you're cold enough, you actually need to make more heat. That's when you start shivering. Muscles create heat when they contract. If, on the other hand, you're too hot, then the sweat glands become active. They produce fluid to evaporate and remove heat. And the blood vessels in the dermis dilate. That means they get bigger. That sends more blood to the surface where it can be released. And this is why people turn red when they're hot. It's not the heat itself that's turning them red, it's the blood coming to the surface to try to get rid of their heat. And then your skeletal muscles don't get involved if you're too hot. Sometimes they can be the cause of it, like when the temperature outside is fine but you're exercising, you're creating more heat by contracting the muscles. And that can lead you to sweat and dilate your vessels. Whereas if you were inactive in the same temperature, you wouldn't be too hot. So if we put them both together in a chart, let's do blue for cold. So stimulus, you're too cold. Thermoreceptors, hypothalamus. That's going to be the same in either direction. Constrict the vessels, contract the muscles. And that takes you back to normal temperature. If you're too hot, you're going to dilate the vessels and make sweat, and that will cool you down back to the normal temperature. Questions on body temperature homeostasis?
My mom has something with her robe when she gets hot. she just turns like super duper red, like she never sweats. I think she has to take like medicine for it. And it's
Yeah.
like,
Some people just don't sweat very well, and so the blood vessels have to compensate. And then a couple of little clinical things we're going to take a look at. Wound healing. Inflammation, which you probably usually heard of as something bad, is actually a normal response to injury. The area gets hot and red and swells, and that's because of increased blood flow. The blood itself brings the heat and makes it red, and more fluid comes out of the vessels, and that's what makes it swell. It's useful because it provides the tissue with more oxygen and nutrients for healing, and it brings white blood cells to fight the infection and clean up damage. Then actually repairing the damage depends on how deep the cut is. A shallow cut that only affects the